Well, hello. My name's Joe Minato. This is the inaugural meeting of the Coriolis Youth Astronomy Club. So what I'm going to do right now is I'm going to share my screen with you, and I'm going to go to my website, tell you a little bit about what the Coriolis Youth Astronomy Club is. Let's see, I'm making a few adjustments here to Zoom, so hang in there a second. There we go. There we go. All right, so my name is Joe Minato, and I have been teaching forever, it seems like to me. I've been earning my living as a teacher for 38 years, since 1984. And I taught the last 6 years at IBWHS High School, and I retired from IBWHS High School. But I'm not really retiring from teaching. I'm just retiring from a formal job. So I'm gonna do a bunch of fun things, and I want you to all know that you're welcome at any of these things. I made a web page for myself, and it's easy to remember. It's joeminato.com. And most of the things are astronomy, which I'm going to focus on today. But real quickly, I also am a private tutor. I specialize in math at any level through early college and physics at any level through early college. And I'm nearly full for the year. And so I have other professional tutors on my website in case you or you know anyone looking for a tutor. Some tutor in person, people have various specialties, but if I can't serve your needs, I'll try to connect you with a other tutor. And by professional tutor, I mean a full-fledged adult, well out of college, someone who's earning their living tutoring, or at least part of their living. And then I have a bunch of college student tutors. Well, actually right now I have one college student tutor. Sol McLean, who is a member of the IBWHS Astronomy Club, went to Malheur Field Station last summer and is a junior math major at Reed and really quite a mathematical genius. And Sol tutors. And I'll probably get a few more college students up there. And that's good because college students often charge less than professional tutors. So if you need a tutor or someone you know needs a tutor and they don't have as much money or they need the specific high-end math that Sol offers, you can talk to Sol. But also, once you've earned my trust, I'll put you, a high school student, on my page. And Brennan was on here. Why are you not on here anymore, Brennan? Is that a mistake?
I don't ever remember being on here.
Oh, well, we'll have to talk
why
about that. Brennan does some tutoring. I know that. And so does Dorian. And I put high school students on there. And then the last one there is me. And you can read all about me, but not now. But also, my wife and I last January, the first Wednesday in January, we started the Smart City Learning Cafe, which is one of the funnest projects I've ever done. And what it is free drop-in tutoring every Wednesday night, 7 to 9 at Fat City Cafe in Multnomah Village. And you can drop in and help people. You can drop in and get help. And you can do a little of both. And it's very, very fun. And it's starting this year, Wednesday, October 5th. So not 2 days from now, but 9 days from now will be our first Learning Cafe. And it will continue every Wednesday that IBWHS is in session. And you need to be high school or older, but you could be college and you don't have to go to IBWHS. But you have to want to come and work quietly, not silently, quietly, get help and get your homework done. It's very fun, very fun. I also train beginning teachers, but you don't need to know about that. So let's go to the astronomy stuff, So the IBWHS Astronomy Club is going to keep doing lots of stuff, and I'm still an advisor to it. But I'm going to do some things independent of the IBWHS Astronomy Club, where anyone from the IBWHS Astronomy Club is welcome, but so is any youth anywhere in Oregon. So I'm hoping, kind of my dream, is that students at other high schools will start their own club and can use the IBWHS Astronomy Club as sort of a template or an example, and we can share resources. So there's a lot of stuff here. For example, I have a personal telescope library, and this part of the web page is not fleshed out yet. That's one of my current objectives. In fact, Ryan Bond, who's here tonight, offered to help me. And so if you need to borrow a telescope, you can borrow a telescope. And I lead star parties. And this one's really fun here. I take youth and other adult astronomers for a week to Malheur Field Station. For many years, it was at Pine Mountain Observatory. We switched to Malheur Field Station. That will probably be the location for this year as well. By this year, I mean 2023. It'll probably be in June. And I don't want to talk a lot about this because I want one of the people in this picture or one of the folks who was at campus, not in this picture, to give a talk to this group about astronomy camp at Malheur Field Station, maybe in a few months. But the basic idea is a group of 12 students and 4 mentors went to the desert for a week and did some real science. It's a science-based astronomy camp. And then I do events in the beautiful mountains in northeastern Oregon, the Wallowa Mountains. And these are astronomy events that are different. They're community service. Is you learn how to lead a star party and to do daylight fun astronomy activities for children. And then you put on a series of events for the people of Wallowa County and the people who use Wallowa County for their summer vacation. There's a big state park there. And so we have a captive audience of families who are on summer vacation, and we do fun things with them. And then the way you get paid for this one, since you're doing community service, is I have a friend, Paul, who has a fabulous property at one of the darkest locations anywhere in the lower 48 states. And then we do 1 or 2 star parties just for you with really expert astronomers helping you become an excellent visual observer. So we're going to do both of those things, astronomy camp at Malheur Field Station in probably June of 2023. And we're going to do the Wallowa events probably in July of 2023. You can tell by the probablys that everything's still being planned. And part of that is you can't plan too far in advance. But part of it is this is a new project of mine of kind of running a youth astronomy club for youth from anywhere. I want feedback from all of you before I plan things too much. Again, I hope someone who went to the Wallowa astronomy events to give a little talk to this group, maybe in a few months, November or December, and we'll finalize all the dates, everything in January for our summer activities. But the thing we're doing tonight is I have decided that the 4th or 5th Monday of every month, we will have on Zoom, Monday night, 7 to 8, a talk specifically designed for young people interested in astronomy. And when I put out the word, I, within like 2 days, filled up my calendar. So I wanted to give the first one, this one, to sort of set the scene. And I'm going to give you one of my favorite talks here in a few minutes titled Making Authentic Astronomical Measurements. And then some of you might recognize some of these names. Mike Reitmeyer, in a month, is going to teach us how to plan and conduct a productive observing session. Michael McKeag is going to teach us how to use our cameras to take beautiful night sky photography. Ethan Siegel, a professional astronomer, is going to give us all the latest from the professionals on the James Webb Space Telescope. Sean Curry is going to teach you how an amateur can detect flares on different distant stars and what we can learn about the stars from that. Rob Brown, who is also a co-advisor of this club, and many of you know, he's going to give a talk on spectroscopy, the colors of stars, and what we can learn from them, and specifically what we can learn from them using the very inexpensive spectrometers that he makes himself. He invented a little spectrometer that he makes out of diffraction gratings, lenses, and his 3D printer, and he sells them. They're not very expensive, and the club has some, I have some, and he's very interested in getting youth involved in visual spectroscopy. That means looking at a star through a telescope with a spectroscope, and looking at the rainbow colors and seeing what we can learn about the star. And then finally, Mary Coolidge, in May 22nd, is going to talk about the importance of dark skies. We also have 2 months where there is no 4th or 5th Monday that's available. That's December and March. And since these filled up, really, people want to speak to you. That's 1, 2, 3, 4, 5, 6 people. I sent out an email and I got maybe 36 hours before they were all filled up. So I'm sort of saving December and March don't have a 4th or 5th Monday that's available. So I might do the 12th of December, the 2nd Monday, or the 13th of March. We'll think about that. Let's let one or two of these happen and see how you like them. All right. Hey, so before no, one more thing. And then I also wanted to say the third Monday of every month, the Rose City Astronomers, which is an adult club, but youth are welcome, has a meeting. And they were, for 40 years, they were in person, then they were on Zoom. And now they're some months on Zoom and some months in person. Whenever they're in person, I go. And their club, you have to pay to be a member. The Coriolis Youth Astronomy Club, all you have to do is give me your email address. It's free. You have to pay to be a member, but I'm allowed to bring guests. And their in-person astronomy club meetings are pretty cool. They're pretty exciting and fun, and you meet a lot of neat people. So whenever they are in person and I'm available, which is most of the time, I'm going to go. And I have a car that has 6 seats. And if anybody wants to ever go as my guest, and I'll remind you a week or so before each one. If it's a Zoom meeting, I'm not going to drive people to OMSI to watch a Zoom talk. I'm not sure that's worth our time. But more and more of their talks are going to be live people in person. And if it is that, and they have like a social hour and people showing things, such, I'll take people. And you can go there on your own to OMSI, or I can pick you up at IBWHS or whatever, and we'll do that. So my main goal is to try to make more opportunities available for youth. Someone asked, does Rob Brown have a website where we could buy a spectrometer? Yeah, or you could just talk to him. So I'll ask that of Rob. I'm talking to him tomorrow. He'd love that. He'd love that. He'd even teach you how to use it. I haven't bought one yet. In fact, just no real reason. I haven't gotten around to it. All right. Hey, any other questions about the big picture before I head in with my talk? Well, if you think of any, put them in the chat and I'll look at the chat questions at the end of the talk. Now, if you have questions about the talk that I'm going to give right now, because I'm sharing my screen, I can't see the chat. So feel free to interrupt me, wait till I get to a pause, interrupt me. And Brennan, if people put questions in the chat, you interrupt me, okay? So
Sounds good.
Now I'm going to share my screen again. Here we go. This is the main talk. Where did it go? It's not there. It's not letting me share that screen. We'll solve that problem. Let's try again. All right, Brennan, can you see a black screen with white writing that says authentic astronomical measurements for astronomers?
I certainly can.
Okay, we're ready to go now. Okay, so this is PowerPoint because I was away from internet for the last few days, so I couldn't use Google. And now I have to remember, how do you hit present on PowerPoint? Because it's different than Google. There it is. I think it's that route right there. There it is. Excellent. All right, so I'm retired now, or semi-retired. I have so many things that I want to do in my retirement. And a lot of them, not all of them, have to do with astronomy and youth. And my wife is an author. She writes books, poetry books, all kinds of books. And she's been encouraging me in my retirement to write a book. And I may or may not do that. But if I do, I think the first candidate for what I would write would be a book titled something like Authentic Astronomical Measurements for Amateurs. And maybe your feedback will decide whether or not I do this. Okay. So this goes back to 1973, 1974. I grew up locally. I went to Rockwood Davis Elementary School. That's out kind of between Gresham and Troutdale. And Mr. Dillon was my 6th grade teacher. And that school was a K6. And then 7 and 8 was junior high school. So in 6th grade, you're the big fish. in the little ponds. And Mr. Dillon was a great teacher, and he was particularly great science teacher, and he knew that I loved science. And he would have guest speakers. For a while, even he instructed my parents that I was not to come to school on Fridays. Teachers could do that in the old days. He said, Joey, that's what they called me back then. He said, Joey's pretty far ahead of everything at school. And if he wanted just to stay home on Fridays or go to work with his dad and do his own studying, it'd probably be more beneficial for him. And I did that. And I did just a gazillion science projects. And Mr. Dillon's brother-in-law worked at Tektronix, which is kind of like Tektronix in the 70s is like Intel now. And I got to see a bunch of engineers working. Just a great out-of-the-box teacher. And we had a running joke because he would teach science to the class, and I would always ask the same question. How do they know that? Because I didn't remember, this is way before Google, way before the internet, but we did have encyclopedias. And he would teach us science from the 6th grade science textbook. And they would say things like, the Earth's radius is 6,400 kilometers. And I said, well, what do you think I said? How do they know that? And Mr. Dillon, being a really good teacher, said, I don't know. Mr. Dillon was not trained as a scientist. He was a good teacher. He said, I don't know, Joey, next time you take a Friday off, why don't you find out? Why don't you go to the local library? We used to do that. We used to go to libraries. Why don't you go to the library and find out how we know the size of the Earth? So I did that. I used to walk down to the Rockwood branch of the Multnomah County Library. I pretty much lived there for 7 or 8 years when I was later a kid, and until I went away to college. I found this picture on the web of the Earth being measured, because that's what I imagined first thing, is somebody took a measuring tape and put it around the equator. As a 6th grader, isn't that how you'd think you'd measure the Earth? Okay, so I want to talk to you a little bit about authentic science. I love this word, authentic. And I don't mean to be a downer or a bummer, but in my 40 years of teaching has gotten less and less authentic every year. And so what is authentic? Well, I'll use our example of measuring the size of the Earth. In this day and age, if you want to know the size of the Earth, you'd Google the size of the Earth. And you'd learn very quickly that to 2 significant figures, it's 6.4 times 10 to the 6 meters. You can get that in miles or whatever you wanted. And you can even Google, how do we know that? And they would tell you how we know that. And that's valuable. I'm not anti-Google. I'm not anti-internet. I think it's good to learn stuff. Sometimes you just need quick facts at your fingertips. But it's quite another thing to say, can I measure the Earth myself? And it doesn't count to Google. I mean, to do the real measurement, to get your feet wet, right? To stay out at night, to hurt yourself, to make mistakes, to get it wrong, to have to talk to people and figure out, how do I measure the Earth? So in this day and age, before we had to go to the library and talk to a librarian and find books and use encyclopedias, now we have the internet. We can find all kinds of YouTube science videos and History Channel documentaries. You can watch those until your eyes pop out. I know a lot of you do. Sometimes that's bad because a lot of the sources are not so great. But even if the sources are good, excellent, in fact, you're only learning part of science. You're not actually doing it yourself. It's not authentic learning. And I'm not against inauthentic learning. It just bothers me that so much learning these days is inauthentic. Nobody does anything anymore. Okay, authentic science 3. So watching this talk is not authentic, but doing the activities, and I said plural, I'll probably only get to one of the activities here. And if you want me to give another talk another day about the other activities, we can do that, because I don't want to go too long today. But doing the activity or activities that I outline here is authentic. So I'm building a website presently titled Authentic Astronomical Measurements for the Youth or the Amateur Scientist or something. You can help me with the title. And I have made over the years maybe 20 different astronomical measurements myself. And I want to put instructions up on the website, and I want people to try them. And maybe that would eventually turn into a book. And if you do any of these, I want you to report your results and critique my work and make it better. Come up with your own measurements that I don't cover. So I know it's got actually a website there, but it's not a live link because I haven't done this yet. I've only been retired a few weeks. You got to give me some time. Okay, so my sample. Okay, so an astronomical measurement. The Earth is an astronomical body. Measuring the size of it is an astronomical measurement. How do we know it? Okay, well, I'll give you a hint. It's not using a tape measure. Okay, that is not how we measured the size of the Earth. That's what we call a direct measurement. If you wanted to measure the size of a basketball court, you could take a friend and a measuring tape, and one person hold down one end, and you could measure the size of the basketball court. You could do that. Okay. Even if you wanted to measure the distance, I went to Eugene this weekend. A school actually that I started 30 years ago was having its 30th birthday, and I went down, and we had a big celebration for the school's 30th birthday. Maybe I'll give another talk someday on nearby nature. It's a school that's almost entirely outside, almost entirely for 30 years. There's little yurts and places we seek shelter, but my dream 30 years ago was to start and run a school where it was all authentic, entirely authentic. That people learned how to build cabins and fly fish, make knives out of obsidian, measure the size of the Earth, build telescopes and such. Well, the school still exists, but it's a different long story why I only ran it for the first 10 years. Family needs required Amy and I to move to Portland, but my friends still run it. It's a great school, and I went to their birthday party. So one of the ways I could measure authentically the distance to Eugene is we drove in a car, and the car has an odometer. So I didn't build the odometer. So if you really wanted to do it as authentically as possible, I'd have to build the odometer, build the car, or I'd have to walk to Eugene. So in this authentic measurement business, there's gradations. It's a spectrum. But reasonably, I was able to measure the distance to Eugene. I-5 from my house to the park where we were having the party is almost a straight line. And we could do that. And that's only from here to Eugene, though. You got to go all the way around the Earth. So you didn't measure the size of the Earth using a tape measure or the odometer on a car. How the heck did you do it? Well, this guy figured it out. Now, I want to be very clear that in this book that I'm going to write, most of the ideas are not my original ideas. A couple of them actually are, as far as I know, but most of them are not. And an authentic idea doesn't have to be your idea. This guy, Eratosthenes of Cyrene, he lived like 2,200 years ago. He came up with the measurement that I'm going to teach you now. So I first learned about this in 1974. Mr. Dillon said, why don't you go home and spend one of your Fridays figuring out how we know the size of the Earth? I went to the library. The librarian helped me. I found a book, and I learned all about Eratosthenes' measurement of the size of the Earth. And I did it. I was 12 years old. I measured the size of the Earth. And that makes me so happy, because that is something I did in my schooling, which is one of the best parts of my entire schooling. And I did it. I got some help from people, and I read a book. I didn't make up the idea, but I did it. And it really excited me. And it made me want to be a scientist and a science teacher. And then I went off to college in 1980. And in my college, I didn't have a television, and nobody did. But my friend John was a year younger than me. Later on in high school, John and I did a lot of science, a lot of authentic science together. A lot of authentic science and a lot of blowing stuff up. John was really into blowing stuff up. We were always very careful. No one was ever hurt. No animals were hurt. Like, there were a few plants hurt, I'm sorry to say. John calls me up in the dorm and says, hey, did you see the Cosmos first episode? There's this guy, Carl Sagan. Back then, none of us had heard of Carl Sagan. There's this incredible TV show, and you should have learned all about it. And that measurement you made in 6th grade, he did it. He tells us about it. Well, this was before the internet. It took me 4 or 5 years before I could get a hold. I found a way to watch some of the other episodes by finding somebody in the dorm who had a TV. But I'm going to show you this little clip here right away. Let's see if we can do this. There was one. Brennan, is that working? Can you hear and see everything okay?
I can hear it fine. It's just the visuals are very laggy.
Okay, well, we'll have to do our best on it. Here, we'll try again.
It's a time when our little planet seemed immense, when it was the only world we could explore. Its true size was first worked out in a simple and ingenious way by a man who lived here in Egypt in the 3rd century BC. This tower may have been a communications tower, part of a network running along the North African coast by which signal bonfires were used to communicate messages of state. It also may have been used as a lighthouse, a navigational beacon for sailing ships out there in the Mediterranean Sea. It is about 50 kilometers west of what was once one of the great cities of the world, Alexandria. In Alexandria at that time, there lived a man named Eratosthenes. One of his envious contemporaries called him Beta, the second letter of the Greek alphabet, because he said Eratosthenes was second best in the world in everything. But it seems clear that in many fields, Eratosthenes was alpha. He was an astronomer, historian, geographer, philosopher, poet, theater critic, and mathematician. He was also the chief librarian of the great library of Alexandria. And one day, while reading a papyrus book in the library, he came upon a curious account. Far to the south, he read, at the frontier outpost of Syene, something notable could be seen on the longest day of the year. On June 21st, the shadows of a temple column or a vertical stick would grow shorter as noon approached. And as the hours crept towards midday, the sun's rays would slither down the sides of a deep well, which on other days would remain in shadow. And then, precisely at noon, columns would cast no shadows, and the sun would shine directly down into the water of the well. At that moment, the sun was exactly overhead. It was an observation that someone else might easily have ignored. Sticks, shadows, reflections in wells, the position of the sun, simple everyday matters of what possible importance might they be. But Eratosthenes was a scientist, and his contemplation of these homely matters changed the world, in a way, made the world. Because Eratosthenes had the presence of mind to experiment, to actually ask whether, back here near Alexandria, a stick cast a shadow near noon on June the 21st. And it turns out sticks do. An overly skeptical person might have said that the report from Syene was in error, but it's an absolutely straightforward observation. Why would anyone lie on such a trivial matter? Eratosthenes asked himself how it could be that at the same moment, a stick in Syene would cast no shadow, and a stick in Alexandria, 800 kilometers to the north, would cast a very definite shadow. Here is a map of ancient Egypt. I've inserted two sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in the shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment. With those tools, he correctly deduced the circumference of the Earth to high precision, with an error of only a few percent. That's pretty good figuring for 2,200 years ago.
Okay, I know the video was a little jumpy, but I think you followed the basic idea. Isn't that an incredible story? And for me personally, okay. Brennan, are you there? And are we back to the Let's Do It page?
Yes, and yes.
Yeah, okay. So you can just Google that, Carl Sagan, Eratosthenes, and watch it with better video. But you got the basic idea. Is this librarian, who was an amazing librarian 2,200 years ago, figured out that by looking at shadows, you could measure the size of the Earth. Now, you have to remember that in the 1970s, what had I been taught? I had been taught in 4th grade history that people around the world thought the Earth was flat until Columbus made his sailing trip. Now, there's a little bit to that story that's true. It is true that non-educated people in Europe had thought the Earth was flat because so much of the great data of the ancient Greeks and Egyptians and Muslims and such was lost during the Dark Ages. And so it is true that a lot of people around Columbus's time thought the Earth was flat and really didn't think he was going to fall off the edge of the coin-like Earth. But well-educated people didn't believe that. And some people even knew the story of Eratosthenes and even knew the size of the Earth. And there's so much more else that's wrong with the Columbus story. So in 6th grade, when I learned the Eratosthenes story, I have to tell you, a fire got lit in my soul about finding the truth. I knew to tell my parents and my brothers and sisters, people made fun of me. My goal in life is to find the truth. And how can you know something is true unless you've measured it for yourself? You've discovered it for yourself. Now, you can't do that for everything because there's only so much time, but I think it's important to do it for some things so that you learn how science really works, so that you get some things wrong and you learn the limitations of science and you learn about how science is a self-correcting process. So it turns out that about 2019, no, that's not right. I think it was more like about 2005. Someone, I don't remember right now, put on the internet teacher instructions and student instructions for how to do this measurement. I'm not going to click that PDF right now because I have excerpts from it in the next few, but all the details are already on the web. It was called the Eratosthenes Project. Somebody at some university got a grant and they put up the instructions. And here's a picture from that. Here's the basic idea. The Earth is the circle. The sun is very far away, so the rays are coming in perpendicular. R is the radius of the Earth. D is the distance along the surface of the Earth from Syene to Alexandria. Okay, so we've got a geometry problem here, don't we? I think you've all taken 9th grade geometry. If not, you're taking it presently, and I think you could do this problem. And Eratosthenes did this problem. Okay, and then if you imagine constructing a tower, okay, a tower could just be a ring stand. It could just be a meter stick that you mount. It could be a broom. It could be a lamppost. Any vertical tower you take and you either construct it or find one. And then the sunlight comes in. And we all know that the length of a shadow changes over the course of the day. And you find when the shadow is shortest for that day. And you've got the measurement of the height of your tower and the length of the shadow. And many of you have learned trigonometry. And for any of you who've ever said, when am I ever going to use this stupid math in real life? Well, I hope none of you have said that, but many students do. Right here, you're going to learn this stupid math to make one of the greatest measurements that was ever made, I think. Not only proving that the Earth is a sphere, but measuring its size. Okay, you're going to measure the length of your meter stick or whatever it's called and your shadow. Okay. And you're going to notice here that this theta here, the angle that goes from the center of the Earth to Syene, and the same vertex to Alexandria, that theta and this theta, they're the same theta, aren't they? Do you remember alternate interior angles? One of your conjectures from geometry? Yes, math is useful. Math is cool, math is beautiful. Those two thetas are the same. Okay, and if you know your trigonometry, you know that tangent of theta is the length of the shadow divided by the height of the tower. Look at that. Tangent theta, SOHCAHTOA, is opposite over adjacent. So it's the length of the shadow over the height of the tower. Sure enough. And then some basic circle geometry. We know that D is part of a circle. So I argue, Eratosthenes argues, that D divided by the circumference of the circle, 2 pi r, is the same ratio as theta divided by how many radians in a circle, 2 pi. So there's a little basic circle geometry from 9th grade geometry. Let's keep going here. And you can solve for r. Remember, it's r we're looking for. It's the radius of the Earth. And it equals d over theta. Okay. Now, when Eratosthenes did this, he only needed what I call the one stick method, because his other stick was in Syene, and Syene was on the equator. So at high noon, the second stick had no shadow. So you can do the same measurement even if one of your sticks is not on the equator, because that might not be practical. So here's a picture of the two-stick method. You put a stick in, say, for example, Portland. Okay, so we could do this here at one of our schools around here, and we have a stick and a shadow. And then another school that's on the I-5 corridor, north or south, maybe Eugene, maybe Roseburg, Medford. We got some students who sometimes come to my talks from Medford, maybe near San Francisco, Sacramento, LA, okay, Seattle, we could go north, okay. We find some students at another school that's along I-5, and we make another measurement. At the same date and time, they measure their stick and their shadow, and we measure our stick and our shadow, okay. It's a little more complicated when you do the two-stick method. And at any rate, you can find theta because you measure the height of your stick, the length of your shadow. So somewhere in there, I think I said, if not, I should have, that you need to make your measurement at local noon. And most students go, local noon? Noon's just noon. Noon's when it's 12 o'clock, just after 11:59, just before 12:01, middle of the day. Well, it turns out it's not that simple, okay? Because we have time zones. So imagine that when it's local noon in Portland, our time zone goes clear over to the Idaho border and clear over to the coast. So local noon is when the shadow of a vertical stick points due north. And that's not going to be exactly the same time in Portland as it would be in Pendleton or Hood River, right? Because there's a time zone, and the time zone makes all of that kind of approximate. But we need to make our measurement at local noon. Well, authentic measurements, we question everything. So it says right there, local noon is the time when a shadow of vertical stick points due north. What's north? There's so much confusion about north, okay? It was another one of my great questions for Mr. Dillon in 6th grade, because I had heard about true north, geographic north, magnetic north, geomagnetic north. Turns out there's a whole bunch of different norths. I have a whole different talk on that, by the way. But for this, we're just going to say, what is north? We're going to worry about true north or geographic north, the north that is determined by the spin axis of the Earth. So how do we know what direction is north? Well, we have to make an authentic measurement. I know you could get out a compass and you could measure north with your compass. But first of all, unless you built that compass yourself, which we could do, but it's not a true measurement. Or many of you might know that the numbered streets in Portland, Oregon run north-south. So I live just off 35th Avenue, 35th runs north and south. So you could use that, but that's not authentic because some surveyor did that for you. How can you authentically determine true north and what time local north is where you live? Okay, so what you have to do is you have to build a gnomon. And it's a cool thing because it's just such a fun word, gnomon. A gnomon is just a vertical stick in the ground. So you take your gnomon, you place it on a flat surface, and you draw the shadow every so often all day. It's an excuse to sit in the sun all day and read a book, set an alarm for every 15 minutes, and boom, draw the shadow. True north is the direction of the shortest shadow. An authentic measurement. Okay, here's a picture of a kid. When I do this with little kids, which I do part of this lesson, they are the gnomon. And the kids get to stand outside every hour or so all day and sketch themselves. And so you can actually do this with you are the gnomon. With older students, though, I do it in a different way. And I did this, I've done this many times, but this was the time that I documented it. March 2020, that was right after the pandemic began. And I had everyone do this at home. And we calculated, the students who did this, all calculated local noon by all they needed was chalk and a stick, a gnomon, and their homework for that day was to lay around, do their other homework, and draw the tip of the stick at the time. And we averaged all the results, and we found out that local noon was 1:18 Pacific Daylight Time. And that's the right answer. That's something you can look at. The US Naval Observatory has the true answer. It's okay when your students to check your authentic measurement against the true measurement. And we did it near the vernal equinox. We just had a couple of days ago the autumnal equinox. It's a great time of the year to do this. So if you wanted to do this activity in the next few days, that would be great. Or we could wait and do it at the vernal equinox. And if you don't do it near the equinoxes, you need to do the two-stick method. Okay. So if you did it on the vernal equinox, your second stick would be on the Tropic of Cancer. There would be no shadow, and theta there would be 0. So here's some pictures of students who sent me pictures of them working from a couple of years ago. They used a meter stick. By the way, I put sidewalk chalk and meter sticks outside the school so the students could swing by and grab them. And they held their stick vertically. And these two, I can't remember if they're sisters or friends or neighbors. They're not wearing masks, so they must be sisters. And they did this, and they figured out local noon. And I had a whole bunch of students do this. It was the pandemic, if you remember, a lot of students didn't do anything. I was a little disappointed in how many students did this, but some did. And Liban, Sapna, Finley, Carolyn, Colin, Blake, Anthony, and Sophie all did it. People used different gnomons: broomstick, scrapwood, pencil, level, a couple of just sticks, pencil, a golf club. And they measured the height of their object and the length of the shadow. They measured it all day until they found the shortest shadow. And you can see that 1, 2, 3, 4, 5, 6, 7, 8 of the 7 students found 1:18 as the time of the shortest shadow. That sometimes happened. Blake, I'm sure, was a great student, but it's normal when you have a data set to throw out the high and the low, throw out the outliers. That's okay. You can't pick and choose your data, but you can throw out the high and the low. And we found then that the time of local noon was 1:18, and then they measured the height of their object, whatever it was, and the length of the shadow. And we're making progress toward making our measurement. And we figured out the average theta then was 0.814 radians, or 46.6 degrees. We made that measurement on the vernal equinox, March 21st, 2020. Local noon was at 1:18, and any vertical object cast a shadow such that that angle, as I showed you in the diagram before, was 46.6 degrees. Okay, now we have theta. We needed to find R. Excuse me, we needed to find D so that we could calculate R. Now, this was the pandemic. How did we find D? Well, how did Eratosthenes do it? He hired a man to walk from Alexandria to Syene, a count of steps, and he'd pace out his steps and get it. We did not walk from IBWHS High School or our neighborhood here to the Tropic of Cancer. Okay, that would have been the most authentic thing to do. But like I said, we're striving for the most authentic measurement, but we don't stop because we can't make a particular measurement. Nobody had the time or the resources to walk to the Tropic of Cancer. So here's what we did instead. We found the National Hurricane Center has a website. I don't know why, of all sources, we ended up finding the National Hurricane Center, but they had a great website where you could put in 2 locations on the Earth, and it would tell you the distance between them, not the east-west distance, just the north-south distance. So some of you may say, well, yeah, but you used a website. That's not authentic. And I'm going to say, correct. You are correct. This measurement was way more authentic than Googling what's the size of the Earth, but it was not perfectly authentic. And can you get where I'm going with that? I'd like to see one or more of you redo this measurement and make it more authentic, right? Maybe make it perfectly authentic. There's always more to do. So I did say we will cheat a little bit. And it's actually not really cheating as long as you admit, as long as you're honest and transparent, it's not cheating. Okay. So now other years, I taught for years in Eugene, and I taught middle school there for years, just to let you know that this is doable. For years, my 8th grade science class, I had friends who were teaching middle school in Seattle, Portland, Roseburg, Medford, all on the I-5 corridor. And we all did the measurement on the same day. And then when families went on vacation and drove the I-5 corridor, we had them measure the distance on their car odometer between, let's say, Eugene and Seattle. Families going on spring break to Seattle, okay, they measure it. And again, that's not perfectly authentic because they did not build their car and they did not build their odometer, but it's more authentic than the Hurricane Center website. And it's still not practical to walk. The neighborhood I taught in Eugene, there were a number of families whose dads were truckers or uncles were truckers. Aunts were truckers, maybe. And we often would use truckers who would often drove the I-5 corridor, and they would measure distances for us between houses. More authentic, not perfectly authentic. And guess what? I've done this project 20, 30 times with 8th graders through college students. We always get within 5%. This year, 2020 at IBWHS, we got within 2.5%. I hope that just makes your jaw drop. We're able to get within 2.5% using, as Carl Sagan said, sticks and shadows and a zest for experimentation. To me, that is freaking phenomenal. You know, I love that. People crowd into sports arenas all the time and go wild when their team wins or makes a touchdown or a goal of some kind. And that's great. I'm pro sports. Though, in my dream, I want people to gather together and just to go nuts when somebody makes an authentic measurement. Call me a crazy dreamer, but that's how I'm going to spend my retirement, is helping youth or anybody who cares learn to make authentic measurements. And hopefully when they present their work, the crowd will go wild. Yay. How do I go to the next page? Okay, so how do we know the true value of the radius of the Earth in 2022? So I said that's homework for you if you want. And the answer is not go to Google. That's not the answer. I mean, how do the people who measure the true size of the Earth, what technique do they use? They don't use Eratosthenes' technique.
Mr. Minato, we have a question.
Yeah, lay it on me.
Sam asks, what's the smallest distance between the sticks you could do this measurement over?
Okay, so that is a fabulous question. And I have never had success. Well, we had success with Eugene and Roseburg. What is that, 100 miles? I never really tried less than that because my intuition suggested that if you need the difference in the two angles to be enough to measure. And remember, most of the times I've done this, it was with middle schoolers, 8th graders, and their measurement skills are not as good as yours. But I do think it has to be, I'm going to throw out there, let's say to be metric, 100 kilometers. But if somebody wanted to do this experiment and try to figure out, could you lower it to 10 kilometers? If you were really precise in measuring that angle, then you actually could walk the distance or bicycle the distance and determine D. That's a darn good question, Sam. So I'm going to say my guttural reaction is 100 kilometers and find out. But the other thing I wanted to say here is, how does NASA or the European Space Agency or geographers, how do we know the true size of the Earth right now? And I think you probably know this already, but you know, the Earth isn't a sphere. It's an oblate sphere. The distance from the center to the poles is, I can't remember off the top of my head, but 20 kilometers or so less than the distance from the center to the equator. That's because of the Earth spinning. So the Earth isn't a perfect ball, awfully close, but it's not a perfect ball. And that has to be measured to incredible precision. How do they do that now? Somebody find out, give us a talk on that. Thank you for that question, Sam. Okay, then. This talk goes on, but I'm not going to go on. So I say, hey, that was a lot of fun. What else can we measure authentically? Well, we can measure the mass of the Earth authentically. Now, this is not a talk I'm going to give right now. If you want me to give this talk on another day, I will, but I'll zip through the slides real quickly. It has to do with density and measuring the density of some common rocks, measuring the density of iron, measuring the density of meteorites, and you learn a lot about the Earth. You can authentically determine the mass of the Earth, and along the way, you can actually discover that the Earth has a core. So here you're not only making an authentic measurement, you're making an authentic discovery. You're discovering the Earth has an iron core. To me, that is freaking crazy, okay? Freaking crazy. Okay, so the crowd really goes crazy for the Earth. All right. Okay, so what else can we measure authentically? What else is going to be a page on my website or a chapter in my book? Well, here are ones that I've done. I've done the distance to the moon, the mass of the moon, the size of the moon, the distance to the sun, the size of the sun, the rotational period of the sun and the moon, the rotational period of Jupiter, the mass of Jupiter, and we've calculated asteroid orbits. Okay, that's some cool stuff that we could do together. Find all those things again, authentically. But you don't have to stick to our solar system. Young people, citizen scientists like yourself, you can measure things in our galaxy, like the distance to nearby stars or the proper motions of stars, the distances to globular cluster, the age of globular clusters, exoplanet transit. Several of you at this talk, I know Hugh Baldwin has measured an exoplanet transit. Okay, maybe Hugh will give us a talk on that. And maybe we could even measure beyond our galaxy, or as I wrote there, to infinity and beyond. So that's the end of my talk. I just hope I got you a little excited, as I am excited, have been excited since sixth grade with Mr. Dillon, about making measurements for myself. I want to end a little philosophically here for just a second. I'm going to stop sharing. Okay. You know, there is news about stuff in astronomy every day, so much that you could read all day and not keep up. Some of you may know that I had to have surgery 6 weeks ago. I'm fine. I'm fine. In fact, I'm going to be better, stronger, faster than I ever was before. But I did have to have surgery, and for a week I had to lay in bed. And then for 2 more weeks, I didn't have to lay in bed, but I really didn't leave the house. I walked slowly with a cane around the house. I did more reading than I've done in a long time, because I wasn't working, I wasn't teaching school, and couldn't do a lot of other things. And even if I tried, even when I was home recovering, I couldn't keep up with all the news about the James Webb Space Telescope, about the NASA DART mission smashing into an asteroid, about the X-ray astronomy things being found, much less learning about keeping up with earth science or anthropology or the COVID pandemic or things. It was overwhelming. Does anybody ever feel completely blown away that there's no way I can keep up with everything? Well, if you do, you're in good company, because I feel the same way. And sometimes it gets me a little down. Not often. I don't get down that often, but one of the antidotes for me is to do something authentic, to do something real, because it doesn't matter how darn good that YouTube video is showing you the latest pictures from the James Webb Space Telescope. You had nothing to do with conceiving the mission of that telescope, of building it, of launching it, of analyzing the data. That's all other people, thousands, tens of thousands of other people. It's an incredible project, and I love it. But I do think sometimes we get overwhelmed by the flow of information in modern society coming into us. And while it's great to learn so much, and we have all these resources, I want to encourage everyone listening to me right now, make an authentic measurement this school year, or an authentic discovery. And if your interest is astronomy, let's do it together. Let's do it together. If you want to do a project for one of your classes or just for the club, one of those things I listed, repeat Eratosthenes' measurement, or do the measurement of the mass of the Earth, or do something more involved using more equipment like he was doing, like using a telescope to measure exoplanet transits. Make an authentic measurement yourself this school year and report back at the end of the year. Wouldn't that be fun? All right. So that's the end of my talk today. I have to go in 14 minutes, but I will stay. I still, believe it or not, I'm tutoring now. I haven't totally retired. I don't usually tutor on Monday nights, but I have 2 students who have big exams tomorrow. So I'm tutoring one at 8:30 and one at 9:30. So I'll be up late. But I would like to hear feedback on what you just learned about. Are you excited about making an authentic measurement? What measurement would you make? I'm going to go right here and I'm going to go to record and